See now, first one, atomic radius we have seen, is it? Now, ionic radii means it is the distance from the center of the nucleus. Where the nucleus will be present, children? Center of the atom, is it? Nucleus. Nucleus of the ion up to the point where it exerts in its influence on the electron cloud of the ion. See where it exerts its influence on the electron cloud of the ion around it, is it? Now you see for lithium and fluorine, what is the difference radii in picometers they have given, that is a relative ionic radii of cation and anion. Okay, you have studied, is it, cation and anion in your lower in your ninth standard classes, and what is the difference between that ionic radii they have given, just for your reference. Okay, then you know that the ions are formed when an atom lose or gain electrons. When a neutral atom loses an electron, when it loses an electron, it becomes positively and it is called as cation. Whereas the gain of electron by a neutral atom, and it gets what, charged negatively, and we'll call them as anion. So the size of the ions is important to determine their behavior in solution. So what we have to do on the structure of the ionic solids, the size of a cation is always smaller than the corresponding neutral atom. Okay, but the anion is always, what will happen? It will be larger. Okay, for instance, lithium and sodium, Li and Na, sodium, what is the symbol? Na, lose the single electron from their outermost energy level. What it will happen? It will lose one energy from outermost energy level, lose on a single electron to form what ion? Cation. Okay, yes, that is positively charged ion. The ions so formed are smaller because the remaining electrons are at inner cells and attracted more strongly by so they are near to the nucleus. So fluorine and chlorine, what will happen means, become negative ions by gaining an electron. When electrons are added to that on the nucleus, it's not great enough to hold the increased number of electrons. So as seen in the atomic radius, ionic radius also decrease along the period from left to right and increase down the group. This point is very atomic radius, what is happening, that is down the group and from top to bottom, that is left to right, that you must know. And in ionic radius, what I said, along the period decrease, left to right increase, from left to right and decrease and increase down the group. Okay, yes, ionization energy is the minimum energy required to remove an electron from a gaseous atom in its ground state to form what ion? Cation, to form a positively charged ion. Okay, it is otherwise called as ionization enthalpy. It is measured in kilojoules per mole. Okay, then higher the ionization energy, it is more difficult to remove the electron. As the atomic size, what will happen as the atomic size decreases from left to right in a period, more energy is required. When it is moving from left to right, what is needed? More energy is required to remove the electron. So the ionization energy, what will happen? It increases along the period, but down the group, what will happen? The atomic size increases and hence the valence electrons are loosely bound. They require relatively less energy for the removal. Thus ionization energy, what will happen? Decreases down the group in the periodic table. You must know this note. As the positive charge increases, the size of the cation decreases. As the negative charge increases, what happens? The size of the anion increases. What happens? The size of the anion increases. So that's what we have seen. Okay, children? Yes.